Hello students, Jai Swaminarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Bhat, Gandhinagar. I am the subject matter of Interconnected Power System subject, which is in the 7th semester Electrical Engineering, and GTU subject code of this subject is 2170901. Students, we are currently discussing the chapter number 3, that is load flow studies, and today we are going to discuss the topic number 6, and this is our lecture number 6, in which we are going to study the various methods of load flow studies. So in load flow studies today we are going to discuss the decoupled load flow method. In last lecture we have discussed the various methods of load flow studies, in which we discussed the Newton-Raphson method flow chart, and then we discussed the algorithm for the Newton-Raphson method, and the power flow through the lines and the slack bus, and the comparison of GS and NR method of the load flow studies. Also we had gone through some examples related to the NR method. So today we are going to start with the decoupled load flow method. It is also called the DLF method in the short form. Now decoupled load flow method, in the decoupled load flow method, this is the method which we use for the load flow study, and the decoupled power flow method is a fast and efficient method of obtaining power flow problem solution. So this method is fast compared to the any other methods of the load flow studies. And the coupling between the active power, see generally we have the connection between active power P and bus voltage magnitude V is relatively weak. So whenever such kind of relation between the P and V is weak, similarly the coupling between the Q and the bus voltage angle delta is also weak. So at that time this weak coupling is utilized in the development of the DLF method. So this is the advantage for the DLF method, that this weak coupling is utilized in the development of the DLF method, and in which the P is decoupled from V and Q is decoupled from the delta. So as we know that we have different buses in the power system, that is PV bus, then the delta bus, and the PQ bus and the slack bus. So in this you can see that whenever we have such kind of weak coupling, then P is decoupled from the V and Q is decoupled from the delta. So with this assumption, the equation number 3.47 that we derived for the load flow studies, that is delta P is equal delta P matrix. We form the matrices by taking the delta P and delta Q. Delta P is the change in the active power and delta Q is the change in the reactive power, where H and JL are the components of the power system, and means the matrix which is multiplied with the delta V and V. So this is the equation where the matrices N and J are small compared with the matrix H and L. So N and J are neglected over here, and the equation 3.51 can be rewrite like this. So delta P is equal to H into delta. So and delta Q is equal to L into in the bracket delta mod V divided by mod V. So this is the equation number 3.5 and 3.53 and 3.52 for the change in the active power and change in the reactive power. Now the solution of this equation is taking less time, means it is less time consuming, and the computer memory required would be also less for this DLF method. Then we have already discussed this equations in the previous theories, that is L dash ik is equal to HIK is equal to mod V I mod Vk mod Yik sin theta Ik plus delta k minus delta I, where theta is the power factor angle and the delta is the phase angle, means phase angle of the power, and this I and k indicating the number of buses, and where HII is equal to minus QI minus BII and mod VI square, and where LI is equal to QI minus BII mod VI square. So this 3.55 and 3.56 describe the H and L matrices are say updated in each iteration using 3.53, 55 and 56. So in order to have the fast convergence, the in the DLF method generally we use the points, that is generally we use the method that is having the points perform each iteration by first computing iteration 3.52 for delta delta. So whenever we can compute such kind of means whenever we compute the load flow studies with the help of DLF method, then perform each iteration by first computing equation, and that is 3.52, which is shown in the previous slide for the delta delta, means change in the angle, change in the load angle, and use the second is use the updated value of delta in formation, and the solving the equation 3.53 for delta mod V. So generally we are going to find the delta delta and delta mod V. So for that we need to keep in mind this this 2 points for the faster convergence of the computation of this system. And the DLF method requires less memory in storing the Jacobian matrix as compared to the NR method, and the time required for iteration of the DLF method is practically the same as the NR method. So in this we can say both methods are fast, and we can choose any of the method for the solution of the load flow studies. And in DLF method greater number of iteration are required for the convergence because of the approximation made in it. So generally we have the approximation while we compute each and every iteration, so that's why in the case of DLF method the greater number of iterations are required. Now the second method, that is various in this various method of load flow studies, that is fast decoupled load flow method, and it is also called FDLF method. So in the equation that we already written in the DLF method, that is means the equation of the power studies using NR method, and that can be written in polar coordinates, say delta PQ delta Q is equal to H and JL in the matrix, and the second matrix is delta V divided by V. So over here you can see that where H and JN are the elements of the Jacobian matrix, so that we already discussed in the NR method. And in the NR method generally we solve the NR method using the Jacobian matrix, and the first step in the applying the decoupling principle is to neglect the sub matrix N and J. So over here we can start this solution or computation by the first step, that is we need to neglect the N and J, resulting in two separate equations, that is delta P is equal to H into delta delta, and delta Q is equal to L into delta mod V divided by mod V. So FDLF method which follows the approximations which are made in the Jacobian elements. So the fast decoupled method, the following the approximations are made in say computing the Jacobian elements, that the first is cos delta I minus delta k is equal to 1, then second is sin delta I minus delta k is equal to 1, where g I k sin delta I k less than or equal to b I k, and where q I is the less than or equal to BII into mod VI square. So therefore we can write HIK is equal to LIK by putting the previous equation, that is mod vi, sorry, lik is equal to minus vi vk bik, and lii is equal to hii is equal to minus bii v square. So this is the equation of qi, hik and lik that we can solve with the help of FDLF method. Now equation 3.52 and 53 can be written as that we are rewriting this equation, and in that equation we put over here the value of say hik. So hik is say delta p is equal to vi vk and say b dash ik and into delta. So this is the equation number 3.60. In that we can write the equation for the delta q is equal to vi vk b double dash ik, and in the matrix delta mod v divided by v. So this is the equation number 3.61, where b dash ik and bik are the elements of say minus bik matrix. So that we already form in the case of say NR method, Jacobian matrix, and the say further decoupling and simplification are as follows. So these are the steps for the simplification of the FDLF method. Then first is to omit from b double dash mode b double dash the angle shifting effect of the phase shifter. So this will provide the better solution of the computation. And omit the mode b dash the representation of those network elements that affect the reactive power flows, and significantly shunt reactance and the transformers of nominal in phase steps are say means the omission of this b dash, so that the elements that means effect of that elements of those means the elements from uh, the elements which are present in the power system which offers the high say reactive power, and the effect of this elements are can be say minimized. And dividing the equation 3.60 and 3.61 by mode vi, and putting vi is equal to 1.0 in the equation. And the fourth is neglecting the series resistance in calculating the element of say b. So with this assumptions, the equation 3.60 and 3.61 are simplified, that is delta p by mode v, because that we already mentioned over here that 3.60 and 3.61 is dividing by mode vi. So the equation will become b dash into delta and delta q by mode v b dash into say delta into mode v. So mode v is cancelled out over here also. So this is the equation that are based on the assumptions that we made for the FDLF method solution. And from this above equation we can conclude that the equation 3.62 and 3.63 both are b dash and b double dash say are say real and sparse, and have the structure of H and L respectively. So that we already discussed what is sparse matrix is. And since they contains only admittances, then they are constant and do not change during the corresponding iterations, and they are to be say calculated only once, and inverted only once during the first iteration. So this is the point that we need to keep in mind while we solve this problem, while we solve any means example related to FDLF method. And they are then use all successive iterations, say equation 3.62 and 63 are solved alternatively by using the most recent voltage value. So this is the means this is the way from we can have the solution of load flow studies by say solving the number of iteration until we not get the sufficient output, means not get sufficient result from the computation data. And this method is very fast, and say convergence is very reliably in 2 to 5 iterations. So the accuracy is very good even for large system, because as I already explained you in the previous slide, that it performs the iterations separately whenever the system starts. So for that, even if the system having more iteration, but the accuracy is very good for the large system. And it is found that a good approximate solution is obtained after first of the second classes. So this is how we can solve the DLF and FDLF method. Now let us discuss the flow chart of the FDLF method, so that will be more clear to you. So first is this is the system which is having the start button. So means program which is resume from over here, means start from over. So this is start, and then the first point that is performed in the FDLF method, that is read load flow data check if the initial voltage and voltage angle are set, and obtain the number of buses from the Y bus. So first of all, we need to form the Y bus related to the number of buses are given, and calculate the matrices B and B double dash. So from that we can set the iteration count, that is KQ is equal to 0, and where set bus count, that is KP is equal to 1. So this is the say iteration count, and this is the bus count. And then after we can find the PI is say over here. You can see that PI K1 for I is equal to 2 1 2 3 2 3, and because we have taken bus number 1 as a slack bus. And find delta Pi K1 over here. You can see that. So for that I is say greater than 2 3 to n. So that is the change in the power, say from the I bus means initial bus to the nth number of bus. And find the maximum say delta P K Ki K1. So from that we can find is delta P K is less than or equal to epsilon D. So if it is yes, then set the KP is equal to 0, and if it is no, then it will follow the number 2. And number 2 is say obtain delta I is equal to minus B. Over here you can see that B dash raised to minus 1 delta P. And find the new values of delta I for the number of buses. And then after K1 is equal to K1 plus 1. So from that we can find that PQ bus is QI is equal to say K2 for I is equal to M plus 1 to end. And for delta QI K2 is equal to means for I is equal to M plus 1, where QI is the reactive power of the system. And this is the condition. For this condition is maximum delta Q K2 is less than or equal to EQ. And if it is no, then this will follow this system will follow this direction. And if it is yes, then it will again set the KQ is equal to 0, and it will perform if KP is equal to 0. If it is yes, then it will repeat the system. And over here you can see that number 3 is KQ is equal to 0, and if it is yes, then find the line current without line charging capacitors. And also find the line flows and line losses. So this will be performed once the system is say satisfied, means is yes, then the in the display we can see the result. And if it is no, then this will repeat the steps again. Over here you can see that I already explained to you. And in the 3 you can see that if it is no, then it will follow this. Find the delta mode Vi for I is equal to M plus 1 to end. And find the new values of mode Vi for say I is equal to M plus 1 to n. And then K2 is equal to K2 plus 1. So this is how we can solve the solve the any of the load flow studies problem with the help of FDLF and DLF method. Now comparison of DLF method and FDLF method with NR method, so that will be more clear to write the theory of related FDLF method and DLF method and NR method. So the point we consider, that is the first point that we consider over here, that is memory requirement. So in case of NR method, it is very high because it has it is having say more number of iteration, and in the decoupled method say least 50% of the NR method, so 50% less memory is required compared to the NR method. And say in the FDLF method, the less 50 to 60% of the NR method. So again you can see that in both the system the memory required will be less compared to the NR method. Now the second content that we take, that is complexity of the method. So when we perform this system using say manually or with the help of any programming device, then it is highly complex. And second case, it is in the decoupled method, it is less complex, and fast decoupled method, it is easier because of the iterations of the matrix equation. So generally we need to solve the matrix related to the number of buses, so that will be more easy in the FDLF method. And then computation time, so computation time required for the NR method is high. Then in the case of DLF method, it is 50% of the NR method and 20% of the NR method and 150% of the GS method. So this is the time for the computation of the data for the various load flow study methods. Now the fourth point that is considered over here, that is suitability. So any large sized power system for accurate calculation, the NR method is used. And for the DLF method, generally we use large sized power system and for the solution. And in the FDLF method, the large size power system say for fast calculation and typically high X by R ratio of the system. And the fifth point that is considered over here, that is uses of method. So NR method is used less compared to the FDLF method. So in the case of DLF method, the use of the method is less, and over here you can see the use of the method is more compared to the NR and decoupled method. And the sixth condition, that is the point that we need to keep in mind while we solving the DLF, FDLF, and the NR method. So sparsity of the Jacobian matrix is first is in the case of NR method less, and in the case of the say decoupled method, it is higher than the NR method. And in the decoupled say FDLF method, it is most applicable for the sparsity of the Jacobian matrix. So this is how we can compare the NR method and DLF method and FDLF method for the load flow studies. So after this topic, you have the worksheet question, that is compare DLF and FDLF method with the NR method. And the assignment questions related to this topic is topic are: first is explain the DLF method with suitable assumption, and the second is the explain FDLF method with suitable flowchart, in which in the second question you have to draw and write each and everything related to the FDLF method, and derive the related means of formulas for the FDLF method. So the instructions related to the worksheet question and the assignment question, which is written below, so please read it carefully. If you have any query or any doubt related to this topic, then we can solve your queries and doubt in our doubt solving session. Also if you have any further query after our doubt solving session, then feel free to call me, and you can take the snap of this slide, so the related instructions and the questions which are written in the slide. So this is how we have reached up to the means we have finished up to the say theory part of this chapter. Then we calculate the examples related to the theories into the next chapter. And there are some more important theories are few theories are left in this in this chapter, that are just say you need to understand just because for to improve your say basics of the electrical power system. So that will discuss in the next lecture. So with this I am done, and thank you very much student. Thank you very much all. Jai Swaminarayan to all. Thank you very much student.